What we're going to talk about today are the well accessories, and we use these very, very often, and it's hard to think of how many components there are on the wells and all the little parts and pieces that go along with a well. All you think about is just a piece of pipe in the ground with a pump in it, but if we didn't have some of these components, it wouldn't even work. The first thing I'm going to talk about is how a well is constructed. It's basically, in the very old days, you used to hand dig a well and line it with cement. There was a bucket and you lowered it down with a rope. Nowadays, the modern well is constructed with either 6-inch or 8-inch or even larger pipe. It's driven into the ground until it gets into the water-bearing soil. I've got an example. We're going to use this as our miniature well today. And this is a 6-inch PVC pipe, and it still represents the same diameter that we're using on most of the wells today. The first component of a well, or of the well accessory, is the pump. We're using just a liquid end today for an example, but this is very, very important. If the well driller or the contractor doesn't tell you what pump he needs, you need to either get with someone or go through the class, a previous class, of how to determine the total dynamic head and everything for the well pumps. Next, we'd have the splice kit. What the splice kit does is it's consisted of a small metal sleeve and a plastic heat shrink tube. And how these work is you'll have your wire stripped back. You'll take the sleeve and slip it on to the wire. Using a crimping tool, you simply reach down and crimp the connector, and that makes it tight. Next, you'll want to slide on the heat shrink tubing. Don't forget to put this on, or you'll have to cut out the splice and try it again. Take the other piece of wire, insert it into the clamp. Get your crimpers lined up, and again, squeeze down the crimpers. And now you've spliced the motor cord to the pump wire. When you're finished with this, you slide the heat shrink tube so it's centered. Then you would take a torch, heat up the heat shrink tube. This would then shrink down around the wire, and that forms a watertight seal. The key thing about this splice kit is you want to make sure it comes with 4 tubes. You want to use 4 tubes. Don't use 1 tube or 2 tubes, because you can see if we were to crimp the yellow wire and we had them both under the same tube, they would touch and short out. Next, we have a torque arrestor. This is the torque arrestor, and how this device works, you would fasten one end tight first on the pipe where you want it. The other end you would just put snug. You would slide it down, get it to the correct diameter that you want it, then tighten it down using the hose clamp on the top. And what this does is it expands on the drop pipe. So you find out what the correct diameter is, then you take your screwdriver and tighten it down. This is the spider. This is another form of a torque arrestor. And what this also does is it's a centering device. It'll keep the pump in the center of the casing. This device just simply slips onto the pipe. You'll notice that it's very snug. That's to keep it from moving around. Okay, and going back to our simulated well, this again will show you how this lines right up and it keeps the pump from slopping around in the well casing. The next component here is the inline check valve. How this operates is it's on the inside, it's got a spring, and on the other side, it's got a bonnet. And what happens is as the water flows through, it pushes the bonnet up and allows the water to flow past the bonnet. When the pump shuts off, the bonnet then reverses itself and seats. You always want to make sure that these are installed in the correct direction. The well pumps that we carry, some may or may not have an inline check valve on the head of the pump. If they don't or do, a lot of the contractors, it doesn't matter. they still prefer to put their own inline check valve. The nice idea or design behind this one is it is 1.25 inches by 1. It's 1.25 inch male thread, which will screw right into the top of the pump, and then they can hang their pump on 1-inch drop pipe. There's two different styles. We have stainless and brass. There are also male thread by female thread and female by female. Another device that we use is a dole flow. This isn't in the outline. This is a specialty item. This would be asked for specifically by the well driller or by the pump contractor. What these are used for is low producing wells, and we would use these if we had a 10-gallon a minute pump. This device right here happens to be a 5-gallon a minute dole flow. It will only allow 5 gallons a minute to be pumped from the well. The interior portion of the dole flow is lined with stainless steel. What this does is if there's any abrasives in the water, it will absorb those rather than having them just go directly onto the diaphragm. On the outlet side is a small diaphragm. What this diaphragm does is it only allows a certain amount of water, like I stated before. It's a small rubber diaphragm in here that has an orifice in it, and the orifice will only allow the required amount of water. These dole valves can be utilized anywhere from 5-gallon a minute, 3-gallon a minute, clear on up to 100 gallons a minute based on what the system design parameters call for. And then we have the drop pipe. There's 3 different types of pipe that you can use. There's poly pipe, which is highly not recommended. Over time, the poly pipe stretches, which in turn puts added strain on the wire, which can cause the wire to break. The other one is the Schedule 80 PVC white drop pipe. It comes 2 ways. It comes with a threaded end that's male, and the other end of the pipe is female, or it comes male-male, and it'll use a coupling, which is a Schedule 80 threaded coupling to join the 2 pieces together. This is the Schedule 80 drop pipe. Typically it comes in the racks like this. The factory will automatically tape bundles of 100 for us to make it easier to pull out for the contractors. We have 2 different styles of the drop pipe. We have the male and female threaded drop pipe, and we have the male threaded drop pipe. Both of the drop pipes are Schedule 80 rated. And with the male drop pipe, what you'll need are the couplings. Otherwise you can't join the pipe together. Simply remove the thread protector. You'll take and put some pipe dope on the fitting, or on the pipe itself. Screw the coupling together. Then the next stick of pipe will screw right into the threads. With the male-female pipe, you would have the male end on one end, and this is the female threaded end, which you would take the male end and screw it into it. And last but not least, we have galvanized pipe. It comes with the thread protectors on the end and not a real coupling. However, the contractors typically use those thread protectors for the couplings. Do not use glue PVC pipe. What I mean by the glue is the bell and spigot end glue PVC pipe. The reason why is if a contractor ever comes back again to do maintenance on the well, it makes it impossible to take it out in the 20-foot sections. They'll be cutting it every 20 feet, and then they'll waste their time, have to put the correct pipe back down the hole. What we have here is a pitless adapter. This is one way to get out of the well. This is a 2-piece device. This piece is on the inside of the well. The pump hangs from it. This bottom part is threaded that your drop pipe would hang on, and then it discharges through here into this area here. This portion of it is on the outside of the well, and what this is it's very similar to a bulkhead fitting. You would drill a hole in the side of the casing, slip this through from the inside. This gasket would then be inserted along with the ring, and if you notice, both parts are concave to go around the edge of the well casing, and then there's a lock nut on the outside that tightens down to hold the entire thing in place, keep it from falling back through the hole into the well. The top portion of this device has threads in it for the pump truck or the pump person to screw their elevator down into when they go to lift the pump out of the well. So when they lift the pump out, all that comes out of the well is this right here. This works really well for 2 options. Number one, if they're just testing the well to see if there's a possible problem with the pump, they can break it loose from the pitless adapter, only raise it to here, turn the pump on and see if water comes out, rather than removing the whole 300 or 400 or 200 feet of pipe out of the well. Another way that we can get out of the well is through a well seal. Now, what the designations for the well seals is there are two numbers. This one, for example, happens to be a 6x1, and what that means is it's a 6-inch diameter well, so it has a seal for a 6-inch diameter casing, by 1, which means it's a 1-inch drop pipe. And if we were to have a larger well, say an 8x2, it would be an 8x2, which means it's an 8-inch diameter casing with a 2-inch drop pipe. It's a 4-piece component, or yes, correct, 4 pieces. What you have is the top plate. This top plate will sit on top of the well casing. You have the compression gasket, which when you tighten these nuts down, it will actually squeeze this gasket out against the side of the casing, as well as compress it on the inside to seal it off, to keep any bugs or anything like that from getting back down the well. And you have the 2 bottom plates to complete the compression. You don't want to go through the top of the well seal with PVC pipe. You want to go through with a galvanized nipple. The reason why is when you tighten these nuts down and it compresses, you don't want to put that added pressure on the PVC pipe. You also want to go into a galvanized T. The reason why is if the well driller has to come back and do maintenance on the pump, he can undo this plug, tie his elevator onto this fitting, whether it's 1 inch, 1.25 inch, 2 inch, whatever it happens to be, and then he can lift out the well pump, taking the seal with him. For maintenance, you want to make sure that you have a union very close by to the well seal also. If we were to come off here with a PVC male adapter or a nipple or something of that sort, then somebody's going to have to cut it instead of just undoing the union and lifting the whole assembly out. That gets us out of the well, and now we're heading into the pump house. There's some basic components in the pump house that you'll need to use. One of them is a pressure switch. This device screws onto the tank T, which we have here, and what this is, it regulates the pressure on the system. Inside, you have screws. These are the contacts for the power. If you're using 110 or 220, if you're using 110, you would only use 1/2 of this just to break the hot leg. You could use both sides and break the neutral also, but it's not recommended. If you are using 230 volt, you would have one hot leg here, the other hot leg here, your pump legs would go out here. What these are small magnetic contacts, just like points in a car. It's activated on and off by the water pressure that's in the system. These are adjustable. The standard range is 40 to 60 psi. Sometimes you'll need larger ones or smaller ones based on the application. The next component is a tank T. What this has are ports for all of the devices that we'll attach to the well, all the accessories. This is a unique device. It's 1.25 inch outside thread, 1 inch inside thread. Typically the water would come in one side and out the other, and your pressure tank would be here. This device, you can put the sample port, you can put the pressure gauge, the pressure relief valve, and the pressure switch all on the same in one compact area. You'll also have a pressure gauge. This shows the system pressure. Like I was stating before with the pressure switch, 40 to 60, you'd want it only to move in that range. If it was moving any higher or lower than that, then you know the system's out of adjustment. You'd have a pressure relief valve. What this does is if by chance the pressure switch fails in the go position and it continues to let the pump run, you don't blow up all of the plumbing downrange. This will open and relieve the pressure in the system. And then you have a sample tap. This is typically just a hose bib, and like I stated before, it just screws right into the tank T. Another version of this would be a garden valve where the actual outlet portion of it is canted up a little bit. Either one can be used. You just have to make sure that you have male thread on the back side to screw into the tank T. On the top of the well, if you're utilizing a pitless adapter, you still need to seal off the top. What we typically use are these Baker Monitor well caps. That's just a brand name. There are other brand names. These are a two-piece device. What there is this is the actual top of it. This would come off and allow the contractor access into the well. The nice thing about this unit is it comes with 2 vent holes to allow the well to breathe, as well as a threaded fitting for the electrical wire that is coming from underground up into the well, so you can wire nut it to the top of the drop pipe that's going down to the well pump. This unit has locking ears. What these do are screw into the top of the casing to keep this in place. In addition to what I've shown you here, we also have created an outline, and you may want to keep the outline handy if you're ever writing up or working with the well components or the well accessories, and you can basically use the outline as a checklist and follow it right on down through. So thanks for watching this video, and good luck in the field.